Hey everybody, this is assignment one for the week of May 4th. This is the last week of new subject material. Next week you will have to turn your entire packet in. Be sure to answer your phone calls, listen for announcement about how the procedure to turn your information in will be. I'm looking to upload another couple of videos probably tomorrow. Sorry this one's taken so long. We had some technical difficulties and I just had to wait until I was able to work those out. So go ahead and get your PowerPoint notes and your packet out to go over this with me. We're going to be talking about segments and circles today. And one of the first things that you see when you're looking at your packet is something like this, and it asks you to find the perimeter. Well, to find the perimeter, you have to know a little bit about tangents. Tangents, as we've discussed in a previous lesson, are lines that touch the circle on the outside. They do not intersect the circle, they just touch it just one time. That point, and there are three of them here, that point is called the point of tangency. Now, any 2 points of tangency, let's take E and D, and let's say those are both tangent, which they are. If they meet, if they intersect at a point outside the circle, so AE and DE, they form an angle. That angle produces two sides that are congruent to each other. So since AE is 6, the segment AD is also 6. And that can be said for any two tangents that intersect. So if you look at BE, it has to be the same as BF. Therefore, we know that BF is 4. Okay? And then since I know that CF is tangent and CD is tangent, since they meet at this intersection, that vertex, we know that CD is also 7. So when it asks you to find the perimeter, you should know by now the perimeter means add up all the sides. It's the sum of the sides. All right, so what you'll want to do, since it's asking you to find that, is just add everything up. Now, what I like to do, I like to pick a starting point on the outside and then go in a clockwise circle. You don't have to. A lot of people would do the 6 and 6, the 4 and 4, the 7 and 7, and then combine those. And you can do that. There's, the rules of addition, the properties of addition say that addition is commutative, so that means you can arrange them in any order you want. I'm going to do 6 and then 4. And as I go, I'm going to cross them off regardless of what pattern I choose, because if I don't, I'll get confused. So the next is 4 and 7, and then finally 7 and 6. Okay, now I left my calculator downstairs and I don't feel like going and getting it, so got to do some old school arithmetic. We have 7 and, nope, that's a 6. 6 and 4 is 10. 4 and 7 is 11. And then 7 and 6 is 13. When you add all those together, it gives you 34. So if you wanted to find the perimeter, this would be 34 units. Okay, jumping into the packet. I'm going to go ahead and get you started with each of these on the packet. I'm not going to work them out in their entirety, but just to get you started. First thing I know is that this segment and this segment are congruent because they're both tangent and they meet in that point. So since that's 7.5, so is this. And then the same thing here. This little guy, he's 3.7. So that means over here is 3.7 as well. Now on the left-hand side, things get a little tricky. This is 7.5 and this is also 7.5. 7.5. Let me find a different pen. 7.5. Now, we don't really need to know that because we have the length of this whole side. But what we need to find is how long this is. To find how long this is, we have to find how long only that portion of the 19.5 is. So that means we just got to take that 7.5 away from that. So a little math over to the side. We're going to have 19.5 minus 7.5, and that will give us this length. Okay, so 5 minus 5, that's 0. Means we're going to have an integer, which will be nice. And then 19 minus 7 is 12. So now I know that this point is 12, which allows me to determine that that purple or pink segment there is also 12. So finding the perimeter. 7.5, that's what I'm going to start with. So 7.5 plus 3.7 plus 3.7 again, plus 7.5 plus 7.5, those are the two green sides, plus 12. Okay, now I have to make a decision. I can use 19.5 or I can use 7.5 and 12. So pick what you want to. In this case, I'm going to not use these two at all. I'm just going to use that 19.5. Okay, now the perimeter just says add these all together. I'm sure you can add. So go ahead, combine those together, find the perimeter, use your calculator. You all know how to add, subtract, multiply, and divide by now. So use what's efficient to get the job done. I am going to go back and erase these. Oh, man. Erase those numbers and rewrite them just so y'all can see them if you want to look back. This is 12 from here. Okay. On to number 47. Since this is 10, so is this. Since this is 7.8, so is this. Now again, we have this whole segment, so I need to find this portion, which is going to be 16.7 minus 7.8. Again, got to do a little math. We got to borrow. Ooh, borrowing. We're going old school there. So we have 17 minus 8, that gives us 9. And then 15 minus 7, that is 8. So this is going to be 8.9, which helps us know that this is 8.9. So everything else should be easy. Again, pick a starting point and then go from there. 7.8. And I highly recommend circling that starting point, because if you don't, you may be like me and get confused. So 7.8, 10, 10, and 8.9. Now getting to this point, you can do 8.9 plus 7.8, or you just can write the whole thing, which is 16.7. This time, just because I want to be different than what I did last time, I'm going to not use this. I'm going to use 7.8 and 8.9. Again, if you wanted to use the 16.7 instead, you can do that. Just do not do both. So from here, go in, add them all up, and you'll be done. Okay, going on to tangents and secants. So this is a tangent because it only touches it. This is a secant because it separates it. So tangent touches, secant separates. It goes all the way through. Now, when it goes all the way through, you have an inside part, which I'm just going to call A for the time being. You have an outside part, which I'm going to call B, and then we'll call the tangent C. Now, when I was browsing Google to find this picture so I could, copy and paste it, I found this. This is how it says to find this. It says A plus B times B equals C squared. And that's the rule. That's the form. That's the formula, if you want to think of it that way. But this is not what helps me. Y'all know I'm about crazy learning stuff. So this is what I teach my class. I tell them the whole times the outside equals the whole times the outside. Ooh, I ran out of room. Okay, if you remember that, and last semester I had some goofy kids, but they called this the whoa equals whoa. So whole outside equals whole outside. Whoa, whoa. If you follow this rule, this will help you for tangents and secants and also to secants. So let me show you what this means. The whole thing. Hold on, I'm getting a crazy lag in my computer. Hopefully this won't set us off too much. This was the problem I was having earlier. Like when it came back, it wouldn't be on track. So hopefully that's not the case because I'm over the technical difficulties. All right, whole. This is the whole line. It's A plus B. Okay. Now, the outside portion is just whatever is outside of the circle. So in this case, it's going to be B. Now, for the next side, you have the whole. So all the way from U to V, from end to end. And that's going to give you, this time, C. Well, look at that outside. If you're looking at just the outside, it's the whole thing too. Like the whole segment is outside the circle. So that's C again. That's where we get this C squared. Okay. Let's go ahead and take a look at that packet. I think the numbers will make a little bit more sense. Number 48. And up here I'm going to write whole times outside equals whole times outside, just so we can kind of refer to that. Okay, 48. The whole thing. It's the part inside, which is x. And when I say and, I mean add the part that it's outside. Okay, so I'm going to do x plus 12. And what I'm going to be looking for in this problem is going to be the x. Now, the outside portion, again, that's just what's outside the circle. And it's going to be 12. Equals the whole thing, 18, times whatever's on the outside. It's also the whole thing in this case. Okay, now we're going to distribute x times 12. That's 12x. And then 12 times 12 is 144. Now, 18 times 18. I don't remember this one off the top of my head. I wish I did. But I don't, so I'm going to multiply it out. 8 times 8 is 64. 8 times 1 is 8. 9, 10, 11, 12, 13, 14.